Let's get back now to what our definition was that when we were talking about a rate. What is a rate? Well, a rate is a special type of what? I'll say it again. I need everybody following along. We are in your notebook, so pay attention, okay? It is a special type of what? That compares to what? Quantities. Say that. Measured in different what? Units. Well, this is a good example. This right here is a good example of what we're talking about. Do we have two different quantities? Yes, of course we do. Otherwise, it wouldn't have been a good example. Okay, this is a good example. So yes, we have two different quantities. We have um, oranges, right? And what? Money. We have oranges and we have a dollar amount, right? Those are two different quantities. We have a quantity of oranges and we have a quantity of money. Okay? So what we want to do now is we want to take that information and we want to write this in, we want to write this as a ratio. And remember I told you that ratios can be written three ways. We're going to choose in this activity, we're going to choose to write our ratios as a fraction. So typically when we're looking for a unit price or unit cost, the dollar sign is going to come first. It's going to go on the very top of what it's going to look to be a fraction. It's actually our ratio. So we're going to have $3.36. Okay. Hey, you're not watching TV here. You got to write down what I'm doing. This is not for entertainment purposes only here. Okay. And then underneath that, we're going to write down what? Yeah, it's 1 dozen, but what we want is the unit price. So there's how many in a dozen? All right, so we're going to write down 12 underneath. Okay, so we have $3.60 for 12 oranges. Okay, now let's get back to this other definition that we had here. This other definition was unit rate, and that is a what? A rate whose denominator is 1. Say that all again. Now, is my denominator 1 here? Okay, no, I've got 12. So who can tell me what do I need to do to the 12 that becomes a 1? Brian, what are we going to do? Right, so let's do this. We're going to divide by 12 here. Now, we've got to keep things equal, right? So if I'm dividing this by 12, what do I have to do up here? Right, divide by 12 as well. Okay? Now, 12 divided by 12, that's the easy part. I get 1. I get 1, right? And that's what I want. But now $3.60, we might have to do that separately. Okay, we're going to bring up our decimal point. Can 12 go into 3? So we're going to need a what? 12 can't go into 3. We need a 0. Okay, we ignore this decimal point now. 12 can go into 36 how many times? 3 times evenly. Now, because we're dealing with money here, we always have to have two places to the right of the decimal point, to the hundredths place, right? Okay, so 12 times 3 is 36. Difference of 0. 12 can't go into 0, so we put there. So, in other words, we've got 30 cents for what? For each orange. So we would write this out as 30 cents per 30 cents per orange. Okay? That's how we figure out the unit rate for oranges. After that last awesome example, this should be no big deal. Again, let's look at rates. It's a special type of ratio that compares two quantities measured in different units. Well, let's develop our rate right now. We've got 24 bottles of spring water for $3.60. So what that means is that I should probably have on the top $3.60, right? And underneath that, what? 24. Good, my quantity. Now I want to make a unit rate, so that means that my bottom number, this denominator, if you will, even though this isn't a fraction, we need to make that a 1. do that, I have to divide that by 24, and to keep it equal, I need to do the top number, divide the top number by 24 as well. So to do that over here, we have $3.60. $3.60 divided by, remember I always told you top dog gets the house. Okay, this is a good example of that. Divided by 24. Bring up that decimal point. 24 can't go into 3, can it? But it can go into 36 how many times? Just once. We're going to have a remainder here. That we're not done yet either. So I have a remainder of 12. Drop my 0 down. 24 can go into 120 how many times? That's very good. 5 times evenly with nothing left. So what this ends up equaling is what? 15 cents for 1 bottle of water. 15 cents per bottle would be fine. Basically, if you haven't figured it out yet, basically what we're doing to figure out unit rate is we're dividing the top number by the bottom number. Okay? And that's really all you need to worry about. I mean, you don't even need to worry about it at all, to tell you the truth. It's pretty simple. Divide the top number by the bottom number, and that is how we will get our. So let's take a look at some other examples, like some that we would find in your book. Number 1, for example, on page 238, we've got a sentence. I'll read it. You follow along. It says, a faucet leaks 668 milliliters of water in 8 minutes. Now, is that already enough that we could come up with a rate? Right? How would we write that? How would we write that sentence as a rate? How would we convey that as a rate, Logan? 668 milliliters on top, and then 8 minutes on the bottom. Yeah, exactly. So that's a good starting point. That's our rate. Now we want to know unit rate, and I already see some of you guys going, all right, well, I know what to do. I'm going to divide by 8, just like I did in my little book. So we've got 668 divided by 8. Guys, go ahead and do that. If you have to add a decimal point and a 0, because you will have a remainder, and it's up to you how you want to handle that. You can take that remainder and make it a fraction, or you can make it a decimal. Either way, you'll be okay, but you will have a remainder on this. All right. So I don't know if you got what I got here. I had 83 and 4/8, which of course can end up being 83 and a half, or you could have written it as 83.5. But here's where I want to get kind of picky. Okay, I want your answer written as a proper unit rate. So it should be 83.5 milliliters per minute. Or you could write per, P-E-R, and that would be fine too. But that's how we do that. If we look at number 2, it says a recipe for 6 muffins calls for 360 grams of oat flakes. How many grams of oat flakes are needed for each muffin? Grams per muffin. So what goes on top? Grams, right? 360 grams for 6 muffins. So we're going to divide 6 into 360. No secret there. Bring down the 0. 60 times evenly. So my answer would be what? 60 grams per muffin. That's one thing that you're going to be held responsible for, or accountable to at least, is understanding what each number represents. If you put muffins per gram, that's not going to make any sense. 60 muffins per 1 gram of oats? That must be some pretty small muffins. You know? It's like a pimple on a Barbie. Okay, let's look at the last one. An airliner makes a 2,748 mile flight in 6 hours. So there's our rate, 2,748 miles in 6 hours. That's pretty good. We want to figure out how many miles per hour that is. It's going to be a little bit faster than your Tahoe can go at home. Or your, yeah, gentlemen. Let's see what you guys get. Yes, Michael. You don't have a marker. Just got a piece of paper. Just start working on a piece of paper. It's all right. This is you know what, Michael? This is our last problem that we're going to do together. As long as you're following along, we're good to go. All right. So how many miles per hour are we talking about? Yeah, we're talking 458 miles per hour. Man, that's cooking. All right. So that's it.